Okay, so we're going to do our first puzzle here for the square root function. Remember, the square root function is basically going to be a scenario that starts at 0, 0, and it goes like this kind of sideways parabola, the top half. Okay, and so if I do not know what it looks like, I'm going to start with the table of values. Okay, and I'm going to start with x and this is y. And I know that this is negative, so I could choose 0 and put 0 in there. Negative 0 is still 0, and 0 squared is 0 is 0. If I put 1 in there, well, then I get square root of negative 1, which blows up as impossible. So this is impossible. It cannot be 1. So what values can I put in there? I want to make this positive somehow. In order to make it positive, if I make x a negative, there'll be a double negative. So if I make x negative 1, in essence, it's going to go the square root of negative times negative 1. Two negatives make a positive, and get 1. If I plug in, let's say, negative 4, negative negative 4, negative negative 4 will be 2. And if I do negative 9, I'll get 3. And so if I consider this, I'm going to make my x and y axis here. We'll make our x and y axis. Okay, and so if I start to roughly put on these points, I know I have 0, 0. I have negative 1, 1. I have negative 4, 2. And so I end up getting this particular graph here. Okay, and so I get 0, 0, labeling 3 points, negative 1, 1, negative 4, 2. This is my pivot point as well. My key features, I know my pivot point in this case is 0, 0. My x-intercept is 0, 0. My y-intercept, 0, 0. And now I know that my domain, if I think about the x values, well, anything going this way, so x is less than or equal to 0. The range I know is going to be, if I think about this horizontal line, values above there, is y is bigger than or equal to 0. We should check with Desmos to see if we're on the right track, so I'm going to go to my Desmos graph here. Let's delete what I have, and I do want to check out if y equals the SQRT, square root of negative x. And indeed, when I look at my graph, I get this scenario here, where that's negative 1, 1, 4, negative 4, 2, negative 9, 3, and so on. Looking good. Are asked to find the inverse. Well, to find the inverse, I switch my x and y, so x is equal to the square root of negative y. Solving both sides, I get x squared is equal to negative y, and so then y is equal to negative x squared. So the inverse function is equal to negative x squared, and this is a function. I have to make sure when I do my inverse, though, it is going to be just, I switch these values, so it's going to be negative 1, 1, or 1, negative 1, negative 1. And so I'm going to get this graph here, and so I know it's only for x values that are positive or equal to 0. It is the same as the range. They switch places. Doing some function notation. The original one, is it reflected over the x-axis? Well, this is the x-axis. It is not. It is reflected over the y-axis. Here's the original graph. It's reflected over y. Vertical, no. Is it horizontal stretch factor? No. Shifted up or down? No, no, no. It was only the reflection over the y-axis. Solving this problem now for here, well, f of x equals 1. And the 1 is equal to f of x, which is this scenario. If I square both sides of the equation to get rid of my square root, I know that this is 1 is equal to negative x, and so x is equal to negative 1 is the solution. If I think graphically, I know this is f of x. Here is the line y equals 1, and I can clearly see this is negative 1, 1, my graphical scenario. So function notation, I'm going to plug this into my function, so I get the square root of negative 12, which is the square root of 12. Well, it says leave in this form. Well, that's going to be root 4 times 3, so I get 2 square root 3. And solving f of x equals 2, well, if I look here, here's my 2. That is going to give me x is equal to negative 4. Just using my table, using the clues that are around that I have, makes life easier. Okay, so now let's do this sketching one here. Sketch the tangent line of a graph by estimating f prime at negative 2. So I'm going to sketch on the derivative at negative 2. Okay, so I find negative 2. Here's negative 2 about here. Here's the x value of negative 2. And so I'm looking for a line that touches just at negative 2. There is a tangent line, and that slope is a negative value. I'm going to say that it is less than 0. It is negative, and that is close enough. All I need for that. And finally, if p of x is root x, what is f of x then? Well, if I know f of x is equal to the square root of negative x. So what do I do to p of x to make it negative x? I make the x value negative, and this will just stay 1. If I plug negative x in for my x, I will get f of x, which is negative x. This one's tricky to get used to. And finally, my composition of function notation. Well, I know that f of x is equal to the root of negative x. So if I'm going to calculate this, I go f at h at 2. I'm going to do h at 2, which is going to be negative 4. F at negative 4 is going to be the square root of negative 4, which is 2. Okay, so a bunch of pieces to the puzzle. Use the clues that you need. In this case, I needed to sketch it. If right off the bat you recognize that that was going to be a reflection over the y-axis, then that's a really quick way to start as well. Think about transformations. But if you don't see the transformations, table of values is always a place you can start. To start you off on puzzle 2, well, here is something going on. I know that this here is going to be a vertical shift by some value. In order to find it, look at my clue here. I have this table and I have coordinates. So I would plug 0 in for x and 3 in for y. I would get 3 is equal to the square root of 0 plus d. And then you can find your equation, and then you can find the rest. I leave this to you now. Good luck.